When thinking about the role of civil engineers during earthquakes, engineering buildings to withstand future earthquakes usually comes to mind. However, civil engineering considerations are also needed in repairing the transportation infrastructure of a country immediately after an earthquake, where many may find themselves in need of assistance. It is important not only to be able to prepare for future earthquakes, but also to be able to respond quickly following one. A specific example from Chile can be seen where in 2010 an 8.8 magnitude earthquake struck the coast of central Chile on the Nazca South American plate boundary. The only cross-country motorway was severely damaged during the earthquake due to liquefaction. Liquefaction is a phenomenon where saturated soil loses strength and ability to support weight under an applied stress or force such as shaking during an earthquake, leading it to behave like a liquid. Rain before the earthquake led the soil to be exceptionally saturated by increasing its relative water content. The ground underneath the critical Chile North-South highway lost its support and was pulled apart due to soil movement below. The holes were filled with gravel and metal plates placed over cracks. Gravel is easy to transport, easily accessible in Chile where it is mined, and has appropriate compressive strength or ability to withstand a pushing force for vehicles to pass over. Metal plates have small deflection under loading and can therefore be spread over large cracks without having to worry about the plate bending underneath an applied force. As a result, the highway was restored in one day and 100 truckloads of aid were able to reach affected areas all across Chile. In this case, the understanding of the properties of soil and materials surrounding transportation infrastructure was useful for civil engineers to be able to appropriately respond immediately after an earthquake.